Hey guys, welcome back. We're talking about triple integrals in Cartesian, and we're starting this next example where it says to set up the integral to find the volume of the region bounded below by the paraboloid z equals x squared plus y squared, and above the sphere of x squared plus y squared plus z squared is equal to 6. So the first thing that we're going to do here is we're going to acknowledge the fact that this sphere is given to you in terms of all three variables. So we want to see, since we're looking at the z-axis, we want to see what z will be equal to here. So we're going to solve for z, which we're going to get z squared is equal to 6 minus x squared minus y squared. And so that means that z will be equal to the positive root of 6 minus x squared minus y squared. So that's actually the upper surface of our curve. And then it also says that the paraboloid that you see here, right, this is actually our lower curve. Well, that gives us to us, they've already given us the equation that z is equal to x squared plus y squared. So we can go ahead, and this is actually kind of nice for us, is that they are already given us the surfaces that we can use to set up our triple integral. So I'm going to go ahead and write down that the upper curve for this is going to be z, which is going to be 6 minus x squared minus y squared. And our lower curve is going to be x squared plus y squared. And this is going to be in terms of f of x, y, z. And we have our first term of dz, right? So that's our surfaces. And so what we need to do now is we need to look at, well, what's going on at our base. And so we always find our other two variables by looking at a two-dimensional representation of what's going on here. So one of the things that we can do is we can actually either set these two things equal to each other, or know that if you see that x squared plus y squared is actually equal to z, then we can actually replace this equation of x squared plus y squared plus z squared equals 6 as z plus z squared is equal to 6. Sorry, that's supposed to be a squared, so let me fix that really fast. Z plus z squared is equal to 6. And so, well, let's figure out what the values of z do we have here. So we're going to go ahead and do z squared plus z minus 6 is equal to 0. And we get that z can be either -3, which won't work because we're positive, and then we're also looking at z can be equal to 2, right? So if we look at the equation of this paraboloid, we can say that 2 is equal to x squared plus y squared, where the radius of this circle is going to actually be the square root of 2. So what I'm going to do now is I'm going to sketch this circle so we can kind of see what's going on with it. And I'm going to go ahead and label our picture, as I always do, with our y and our x. And I'm going to go ahead and add ourselves a little circle in here. Oops. See if I can move that little guy over here. All right, perfect. All right, and so our radius is going to be square root of 2, square root of 2, negative square root of 2, and negative square root of 2. And so what we always want to do to find the other two is we can look at an equation. So we need to have an equation, and then we need to have our bounds. So it does not matter what order you put them in. So I'm going to go, even I did dz, dx, dy in the last example. So I will just kind of stay, and actually let's do something different. Let's do dy. So then I know that I can solve for y here. So remember that I've got function that y squared is equal to x squared, sorry, 2, my apologies, y squared is equal to 2 minus x squared. And so y will be equal to the positive and the negative square root of 2 minus x squared, where this top region, right, so this region right here is going to give you the square root of 2 minus x squared, and the bottom region is going to give you the negative 2 minus x squared. So what we can do now, if I want to do it in terms of y, is I can say I want the square root of 2 minus x squared here, and then the negative square root of 2 minus x, x squared there. I think I was trying to put a y there. And so then the last thing that we have to do in this bounded region is then look at, okay, well, what are the x components, right? So I now need to see my respect of x. And so my left-hand side of x is actually at the negative square root of 2. So I'm going to go ahead and write down my coordinates, because remember, our outer integral has to be values, has to be our bounds. And the right-hand side, the furthest right-hand side we have here is going to be the square root of 2. So remember that this was the left bound, the right-hand bound. This was the upper bound in terms of y, and the lower bound in terms of y. And so we have to just remember that when we do this, you always can go back and say, okay, well, these were in terms of an equation, a surface of z. These were our curves for y, and these were our values for x. And so that's what you'll do for this problem. All right. So that's it for this video. I hope that everything made sense, and I will see you guys in the next one. Take care.